I I think it is time for us to start. So, namaste, good afternoon, everyone. My name is Dr. Shailesh Agrawal. I am Executive Director of Building Materials and Technology Promotion Council, and I extend a very warm welcome to you all in this webinar series, which is on e-learning sessions on innovative techniques in new age construction on behalf of Ministry of Housing and Urban Affairs, Government of India, on behalf of BMTPC, GIZ, and on my personal behalf. Firstly, I would like to extend my very warm welcome to our international experts from Fraunhofer Institute for Building Physics, Simon and Sibine. Sibine, how are you? I think Sibine was here in Delhi last week, and it's really very nice to see you again. And she will be delivering a detailed presentation on thermal aspects and energy efficiency and other sustainable features. I would also like to mention the name of Shri Kuldeep Narayanji, who is the Mission Director and Joint Secretary Housing for All Mission in the Ministry of Housing and Urban Affairs. But for his constant motivation and guidance and faith on all of us, the conduction of these webinars smoothly across the country at regular intervals would not have been possible. I also greet and welcome R.K. Gautam, who is Director Housing for All 5, Manish, who is the lead of Project Management Unit of Pradhan Mantri Awas Yojana, Nitin Jain, Director Climate Smart Buildings, GIZ, and Govinda Somani of GIZ, who is also the co-host of this webinar along with us. I also extend very warm greetings to all other officials from Ministry, PMU team, and GIZ team. The dignitaries, engineers, officers from state governments are also welcome, including SLTC, CLTC team, engineers and architects of other state level agencies. The representative of construction agency, which is Magicrete, in this particular case, which is for Ranchi, and their entire technical team who are executing the project are also welcome to this webinar. At last but not the least, I also extend my good wishes and welcome to all Technograhis who registered through online enrollment drive initiated by HFA Directorate, and they have been participating in all the webinars enthusiastically in such a large number. We have more than 38,000 Technograhis registered so far, and all of us who are attending today's webinar, if you are not yet registered as Technograhi, please do that by visiting the GSTC website. You have to just upload your photograph and Aadhaar details, and you will become the Technograhis. And on the lines of Swachhagrahi and Satyagrahi, these Technograhis are the change agents to bring technology transition in the construction sector. In addition, we also have engineers, architects, students, professionals who have joined us from different parts of the country. You all are welcome here in this webinar. We have already completed 2 rounds of these webinars at all 6 Light House Project sites last year, and now this is the 3rd series. In this 3rd series also, 4 webinars have already been held, respectively on LHP Rajkot site, LHP Chennai site, LHP Indore site, and this is the 5th one, which is on LHP Ranchi. Like in earlier webinars, we will briefly explain you all about the 54 proven innovative construction systems which were shortlisted through GSTC India and being promoted within the country, followed by an exhaustive technical presentation on the specific technology, which is 3D volumetric construction being used in LHP Ranchi. In addition, our international experts from Fraunhofer Institute for Building Physics, Germany, will be sharing their international perspective on these innovative technologies and will focus on the use and adaptation of these technologies so as to enhance thermal comfort, energy efficiency, and affordable housing. Dear friends, the entire proceedings of today are also being webcast through YouTube Live. Also, the presentations being made in today's webinar, along with recordings, can be accessed through gstc-india.gov.in website after the event. In order to give you brief background, let me tell you that to showcase these innovative construction systems, 6 lighthouse projects are being implemented in 6 places, namely Rajkot, Chennai, Indore, Lucknow, Ranchi, and Agartala. The LHP at Chennai and Rajkot is completed. At all these 6 lighthouse projects, 6 distinct innovative technologies are being used, and we are holding these webinars at all the 6 places for participants to get hands-on exposure and opportunity to learn about these innovative construction systems. These lighthouse projects are also being projected as live laboratories, which means learning the different aspects of design and construction during implementation at LHP sites. We have planned whole set of activities at LHP sites, which included webinars, webcasting, physical training, site visits, and interactions. Also, the Ministry of Housing and Urban Affairs, in association with GIZ, organized physical and virtual training programs called Rachna, not only at this lighthouse project site, but also in different parts of the country for educating the different stakeholders about innovations and also about the functional aspects, which are sometimes very important, like thermal comfort, affordability, energy efficiency, resilience, and green interventions. We have already started another set of Rachna program. 2 such programs have already been held in Chandigarh and Bangalore, and the next physical training under Rachna will be held in Kolkata. In case you are a professional, MoHUA, in association with the School of Planning and Architecture, New Delhi, and BMTPs, is also running an online e-certificate course on innovative construction systems called Navriti, where for 8 days, 3 hours each day, detailed lectures, presentations are made by experts from academia, industry, and research institutions, followed by interactive session. The 16th batch of Navriti course will start from 27th October to 2023. So after 2 weeks, and if you want to understand more about these technologies and learn more, you can register for next batch by visiting GSTC website or BMTPC website. So dear participants, by running so many programs concurrently, Government of India is offering all of us a unique opportunity to learn the field level application of innovative construction systems in real time and build capacities so that these systems can be further adapted suiting to our requirements and geoclimatic profile and replicated in our future construction activities. The use of these innovative construction systems is more relevant and pertinent in today's context, as globally we are committed to bring resource efficiency, energy efficiency, eco-friendliness, and disaster resilience, and lead our country towards sustainable and inclusive development. Also, to keep pace with the rapid urbanization, we need to fast-track construction of buildings and infrastructure, and these technologies, which we are going to deliberate in these webinars, impart not only speed to the construction activity, but also help deliver superior quality, affordable housing, which is better in terms of structural and functional performance than the conventional cast-in-place RCC framed and load-bearing construction. Let me also share with all of you that one of the lighthouse projects at Chennai, comprising of 1,152 dwelling units in G+5, that means 6-story configuration using precast concrete construction system, has already been completed in a record time of 12 months, despite of COVID disruptions, and was inaugurated by Honorable Prime Minister of India on 26th May 2022. In fact, Honorable Prime Minister gave the keys to the beneficiaries. The Lighthouse project at Rajkot is also completed and handed over on 19th October 2022 by Honorable PM. In Rajkot, structural work of 4 housing units is being completed in 1 day, and a tower of 14-story was completed in a record time of 32 days. Also, the project at Indore and Lucknow, along with Ranchi projects, are at the advanced stages of completion, and very soon these projects will also be handed over to the beneficiaries. The completion of these projects, despite of COVID, disruptions, corroborates the very fact that these innovative construction systems reduce the construction time by 50% and offer much superior, affordable, and quality homes. The on-ground completion of the project is also a testimony to the efficacy of these innovative construction systems as regards speed, quality, and other hosts of not only structural parameters but also functional parameters. You all are strongly advised to visit these projects. Anytime you can go visit these projects and learn about the implementation of these innovative construction systems in our country. The flow of today's webinar is as follows. First, a short film on LHP at Ranchi will be shown to all of you, followed by two technical presentations. First will be the overall overview of 54 technologies which have been shortlisted through GSTC, and second would be on specific precast concrete construction 3D volumetric, which is the technology used in this LHP Ranchi. We will then have our esteemed international expert to give their perspective on these innovative technologies. Later, if time permits, we will have Q&A, question and answer session. Otherwise, also you can write your questions in the chat box and we will try to revert back and try to answer your queries, if any. I sincerely hope you will all be benefited by this webinar and learn new methods of construction, which will help our country in our future endeavors. Now, I would request my colleague from BMTPC to first run a short film on the LHP at Ranchi, and then make the presentation on the 54 technologies, followed by presentation on Ranchi. So over to you, Jha and Pankaj. Thank you.
Ministry of Housing and Urban Affairs, Government of India, has initiated Global Housing Technology Challenge India to identify and mainstream best available global technologies so as to bring paradigm shift in the construction sector. 54 innovative technologies put in 6 broad categories were shortlisted during the challenge process. 6 lighthouse projects at 6 locations with 6 distinct technologies are being constructed. Light House Project using precast concrete construction system 3D volumetric with 1008 dwelling units in G+8 configurations. Along with all basic and social infrastructure facilities is being constructed at Ranchi in partnership with State Government of Jharkhand. Honorable Prime Minister laid the foundation stones of 6 lighthouse projects, including at Ranchi on 1st January 2021.
आज गरीबों के लिए, मध्यम वर्ग के लिए, घर बनाने के लिए नई टेक्नोलॉजी देश को मिल रही है। ये 6 लाइट हाउस प्रोजेक्ट देश में हाउसिंग कंस्ट्रक्शन को नई दिशा दिखाएंगे। रांची में जर्मनी के 3D कंस्ट्रक्शन सिस्टम से घर बनाएंगे। इसमें हर कमरा अलग से बनेगा और फिर पूरे स्ट्रक्चर को वैसे ही जोड़ा जाएगा जैसे लेगो ब्लॉक्स के खिलौनों को जोड़ते हैं।
Due to ground level issues, the actual construction work of LHP Ranchi could start only in August 2021. The construction work of this project is now in full swing. This 3D volumetric construction system is being used first time in construction of houses under PMAY-U. In this fast-track system, solid precast structural module like room, toilet, kitchen, bathroom, stairs, etc. are being cast monolithically in casting yard at site in controlled conditions. In this modern system, Construction begins with keeping the design foundation of the building ready, while manufacturing of precast concrete structural modules is taking place in the casting yard. Finished rooms, toilet, kitchen, bathroom are then installed at the site with the help of tower cranes. Cable and walls are positioned to terminate the sides of building. Pre-stressed slabs are then installed as flooring elements. Rebar mesh is placed for structural screen, thereby connecting all the elements together. Consecutive floors are then built in similar manner to complete the structure. About 90% of building work, including finishing work, is completed in the casting yard, which saves overall construction time. Casting yard adjacent to the construction site in Ranchi with all facilities is now functional and is being used for the production of preset 3D and other components. While casting yard facilities was being established, raft foundation for all 7 towers were initiated, which are now at different stages of construction. Once foundation work up to grid slab is completed in a tower, preset 3D components getting ready in casting yard will be installed at the site to complete the tower. With all these parallel activities, the project is progressing well and is expected to be completed well within stipulated time. There is tremendous response for booking these houses by beneficiaries. The LHP Ranchi is serving as live laboratory for learning. About 200 Technograhis and other stakeholders have visited the site to learn the use of innovative technology in real project at site.
Afternoon. My name is Pankaj Gupta. I hope I am audible and my screen is also visible to you. Can anybody can confirm it?
Yes, go
Am
ahead.
I audible?
Yes, go ahead.
Yeah. Okay. Thank you, sir. My name is Pankaj Gupta. I am from Building Materials and Technology Promotion Council. The film which you just saw, it was somewhat older. My colleague will be showing you the latest development in this project, and it is almost in completion stage. Meanwhile, I will start with the presentation on the technologies which were global housing technology challenge, and otherwise also these are the systems, alternate systems, which are you can say alternate to the conventional systems which are prevailing right now in India. I would like to start with the Pradhan Mantri, just to tell you about the Pradhan Mantri Awas Yojana, urban, before starting the technology part, just to give you the genesis. This scheme is one of the biggest, or you can say the biggest scheme in the world, implemented since 2015 in the country, and the objective of the government of India is to provide pakka houses, which are all-weather series in urban areas of the country. And basically, this scheme is being implemented through 4 verticals. The first one is the beneficiary-led construction, where the beneficiary himself is constructing his houses. The money, the funding part from the state government and the central government is given directly to the beneficiary, and with his own contribution, the beneficiary is constructing their own houses. Second one is affordable housing in partnership, where you can say the private builders who are having the land or have land, vacant land, and there are guidelines. They will have to construct a minimum number of EWS housing also if they want to cross-subsidize sizes of the houses like MAG and HIG. And the third one you can see is the in situ slum redevelopment, where the slum site itself, and the basic model is like affordable house, but it is on the same location, and the beneficiaries who are already there on the slum, they are given the houses. And the last one is the credit linked subsidy scheme, where the interested in buying the houses directly from the market, they get a subsidy on the interest subsidies. Basically, 3-4 categories are there, starting with the EWS, LIG, MIG. Verticals, the idea was that all kind of beneficiaries who are eligible could get the houses through verticals, so that it becomes, if somebody is eligible with the in situ or CLSS, whatever means the comfortable vertical to the beneficiary, they could adopt it. That was the idea. Just to give you the current progress of the scheme, as you can see, the overall approximately 119 lakhs of houses, 11.9 million, you can say, have been sanctioned. Out of those, around 113 been grounded, the construction is going on, and 77 lakhs are already completed. So this is the current scheme, and you can see the size of the scheme. We have more than 100 lakh houses under this scheme, which as I told you, this is the biggest scheme in the world, you can say. And the different pie charts you can see are the different BLC components, AHP, CLS, as you are seeing. The biggest one, as you can see below, is the orange one, where almost 74 lakh houses out of 119 lakhs, or you can say almost 2/3 of the houses are being constructed by the beneficiary. Background, now I will be to the technology part. Honorable Prime Minister, when the scheme started in 2015, actually it was during one meeting, the discussion was going on, and one demand came from the various states that the demand is going to be more than one. Then, and the scheme was, the duration of the scheme was 7 years from. Point was that how is it possible to construct more than 1 crore houses in 7 years with the conventional systems, which are slow paced, and the resources and the labor part and the manpower part, how it will be possible to construct these many houses in a duration of 7 years. This idea came, and Honorable Prime Minister said that why don't we get with the new technologies which are faster, and we can construct the houses, better houses, and better quality, and faster than the conventional system. This idea, the Global Housing Technology Challenge, was conducted in 2019. And as you can see, 54 technologies were shortlisted, and these were categorized broadly into 6 categories. And these are the 6 categories under which basically we can put all the technologies depending on their type of material or type of construction or point of view, you can say. So all the technologies, we could group them into 6 categories. So these are the 6 categories we will be discussing briefly here. As told in the movie also, and as also that 6 Lighthouse project, the idea was that to implement and showcase this technology on the ground, it was decided that at least one lighthouse project should be constructed out of each category. So accordingly, 6 states were identified and hello. Your mic? Mr. Patra.
इससे पहले वो 18,000 का रन भी किया था उसके बाद तो रन भी किया था
पंकज सर आप म्यूट में हैं अनम्यूट करके करिए
Is it okay now?
Yeah, okay. Please.
This is the slide. You can see the connection system which is prevailing now in the country. The load bearing, the brickwork, you can say, where the load is being taken by the walls itself, and the other one which is more prevailing and now everybody. Everybody, all the technology which is more prevalent of the construction system is the RCC, where beam column slab system. Now starting with the first category, which is the 3D precast, you can see from the photo itself, or in the movie, if you have seen the Ranchi movie just shown, the module is precast. The whole module, the walls, slab and floor, all the module is precast in the factory itself, and then the whole module is brought to the site and assembled at site. That is why we call it 3D. Instead of separate components, the whole module is precast and brought to the site and assembled. That's why we call it custom. This is how you can get an idea from this sequence where the reinforcement cage is there, and then after doing the casting here, the module is ready and at the site and assembled. This is the technology key. Here, this is just site photograph where G+8 construction is there, and on the right you can see that how the modules are brought, and not all the houses are done with the total house is not done with the modules, but some 2D wall components are there. The detailed presentation will be done by my colleague Mr. Jha afterwards. So this is the technology. You can see how it looks after construction. The second category we have is the 2D. The earlier one was 3D volumetric. In 2D, what we are doing is that all the components of the building or the frame, you can say, customized in the factory, and we can do the casting of beams, columns, wall, slabs, staircase, everything separately. And then we can assemble them at the site. That is the basic difference. Here you see the various components, including the staircase, wall panels, or the roof panels also. The factory of how the slab panels are cast. It's a very sophisticated factory. As you can see, this is the factory set up by BG Shirke. These are the components you can see which are cast basically in the factory itself. This is how it looks like, that all the beam columns you can see, if you can make out, these are partially precast with some reinforcement coming out at the top for the connection with the slab and other components. This is how the beam and columns are erected at site. And after this, how the slab is put on those beams and columns. And you can see from this photograph that columns and the reinforcement from the slab itself is coming out. These are all, you can see, say the partially precast type of components. And after putting the slab, you can see this is a broader photograph from the site of the Light House project at Chennai, where you can see now the slab has been put, and then after this, the concrete screed is put, and the concrete, after putting the concrete, this becomes all the joints are filled with the grout and the concrete, and then the whole structure becomes monolithic. This is the view of our Lighthouse project at Chennai. You can see how it has come up with technology. We have 1152 houses, ground plus 5 structure, and 12 blocks were there. And each block was having 96 houses, 16 houses at each floor level. This is how it looks like. And it, coming to the third category, which is our steel structure, pre-engineered steel structural system. In the photograph itself, the whole frame of the building is replaced by the hot roll system in place of RCC beams and columns. A hot roll beam column, and even the deck slab sheet, and then reinforcement is put. So this is the staircase, and everything is done with the hot rolled steel. This is the basic difference between the standard RCC frame and the steel frame. And closer look, you can see the beam columns, and in this system you can use various type of walling depending on the availability or what suits you best. Here the dry panels have been. Idea is, since steel construction in itself is a dry construction, normally it is preferred to use a dry infill walling system also, so that it becomes very fast as compared to the conventional masonry. The second variant in the steel system is the light gauge steel system. We call light gauge steel frame LGSF. You must have heard the generic term we are using, LGSF, where you can see in this photograph, the whole system is being replaced with the galvanized steel sections, which are very thin actually. It becomes a whole frame kind of system. Instead of beam and column, it is a whole frame. You can see using this galvanized sections, and then load is taken by this whole frame instead of beam and column. But normally we recommend this construction up to G+3 as a load bearing. This will make you more clearer with some bracing also depending on the requirement of the building, and this is how it is being constructed. And normally we recommend G+3 with this system as a load bearing. Otherwise, you can column frame and in between infill walls with this LGSF system. Done. And this is the technology we are using in our Lighthouse project at Agartala, Tripura. And here you can see actually this structure, if you see, G+6 actually. And that's why we have used a hybrid system where the beam column frame is there. This is the shaft, RCC shaft for the lift, and in between the infill, if you can see, it is basically a LGSF frame. So this is the hybrid system we are using, and the fascia what we are using here in this case is the precast panels, concrete panels on both the sides, and in between these panels we fill the lightweight concrete. But you have different options. In place of concrete panels, you can use cement fiber boards or other kind of boards on both the sides, and then for the insulation or filling the gap in between, you can use mineral board or insulation also. So you are available for the fascia and inside covering. The next category we have is the fabricated sandwich panel system. In fact, lot types of panels are available in in the market right now, and you can see the EPS, the expanded polystyrene core panel, and then fiber cement board, MGO board, AAC panel, all various kinds of panels are available in the market, and we recommend these panels are not normally not load bearing. And so we recommend these system as I said, it is best to use them with the steel system construction dry, or if you want, you can use these panels with the RCC frame also. So these are basically a replacement of, you can say, your conventional brick masonry. And once you get the frame done, you can get these panel walls, dry walls with these panels very fast. This is one of the most popular category with the panel polystyrene. If you see this panel, expanded polystyrene, comes what we call white lightweight material thermocol, which is used for the packing of white goods and appliances and all. But that is for the packing and all. But here the basic composition is same, but some chemical properties for construction purpose. The chemical composition making it fire resistant also, and for the durability purpose also. But the basic material, just to understand, is the thermocol type. So that's a very, very light material, as you know. And you can see type of vents and walling, staircase, even slab we can do. And here on the right side, you can see the core panel is there. Actually, on this panel, you have a welded mesh of 2 to 3 mm GI wire. Gives overall strength to the panel and takes the load also as a composite panel. And above this panel, you have shotcreting done, and then on the top you have the paint, or doing the putty, you can do the paint. So on this panel, you will have to do plastering, you can say, or graniting you will have to do. But since this material is very light, so it is very fast in execution, and the thermal efficiency of these EPS panel is very good as compared to the other materials. Other type of panels, actually this panel I'm showing you because these one of the categories were the prefabricated panels, and our Lighthouse project at Indore is being done with this panel. We call it cement, EPS cement panel. Actually, it is a composition of EPS, the expanded polystyrene, in the form of beads. Small beads are there in the composition of, in a mix of, you can say, fly ash cement and other adhesives and other bonding materials are there. And on with this mix, and on both the sides, cement fiber board, this panel is manufactured in the factory. Just to give you an idea, this is how it looks like. This material is that composite material, and both the sides, the cement fiber board is there. Normally, the up to the height of the floor, and the width we get is 610 mm, around 3 feet, and then the thickness varies depending on your usage and requirement of. These are having ton and groove system, so that they can be easily connected at site. This is how it looks like in the factory. They are packed and manufactured. And this is, as I told you, a view of how these panels, since these panels are also not load bearing, so we are using these panels with as a hybrid system with steel frame, hot rolled steel beam and column frame, you can say. And these are the panels we are using as the infill walls. So we have been able to do it very fast because of the dry wall system, and the slab in this project is also being used. The sheet, and then a nominal reinforcement, and then the concrete. This is how it looks like. the next slab, you can see how our Indore project is ready, and it's looking like as on date. It is already, and this is how inside of a sample house here in Indore. This is how it is. +8 building with stilt for the parking in this building. Now coming to the next category, which is monolithic concrete construction. Here you can see that we are replacing the whole frame of RCC with aluminium shuttering, which is replacing our frame system. The whole aluminium shuttering is put to replace beam and column structure, and even the walling, the whole walls, including slab and floor, everything is cast using this aluminium formwork, and you don't you 100% monolithic structure without any joint. Otherwise, you go with the column cast afterwards, although that is also a monolithic structure. But here, get the completely monolithic structure in one go casting. You will get a more idea from these photographs. Once the casting to the shuttering is taken to the next level and the reinforcement done, and like you can see in this photograph, around 4 houses are there, and the shuttering has been done, and it will be cast in single pour. There is no need of doing separate pouring. This is how you can get some more idea how the foundation, normally the strip foundation is there in this case, and after doing the shuttering, and then you go, shuttering is taken. Normally you can get a cycle of 7 days, 5 to 7 days easily of one floor. Advantage you are getting is you get the walls when you are doing the normal RCC frame. You have to remove first the column are done, and then do the beams and slab, and then you remove the shutting, and then go to the next level, and then the masonry is to be done separately. But in this case, you get the whole building or outer of the building, including the internal partitions with these walls, in one ready. Next day, you can open the shuttering, and only the shuttering for the slab is kept for a few days. Otherwise, you can take the shuttering after 2-3 days, and you are ready for the next shuttering within a maximum within a week. This technology has been used in our Rajkot Light House project. The technology was somewhat different in the sense, if you see this photograph, this was a tunnel form. Instead of the aluminum shuttering on all the sides with the roofing, which is the separate panels which are connected around 3 to 4 feet, 3 feet, I think, maximum. And the height of the panel is up to the height of the ceiling. So those small panels are aluminum panels are connected, and then shuttering is done. But in this case, we call it a tunnel form here. If you can get an idea, the whole frame or the outer part of that building or the floor, they are two inverted L's, you can say, and then the whole system becomes a tunnel with the joining two inverted L's, and then it becomes in the form of a tunnel. Shuttering separately for the slab also and for the sides. After joining these two components inverted, it becomes in the form of a tunnel, and fast you can get the, and here also the single pour concrete is done, and then you can go to the next level, and immediately next day shuttering, and the whole tunnel comes out, and you take the tunnel to the next level. So the advantage here you get as compared to the aluminum shuttering is you will have to remove all the panels, small down and then you take it to the next level and join them again. That takes a lot of time. But here the whole tunnel formwork comes out after casting, and then you can take directly to the next level. It's similar to the aluminum formwork system. Of these buildings, and very fast we could get the construction done in 45 to 46 days. We could cast 2 blocks of steel plus 13 floors. You can say that how fast this technology is, that with alternate shifting of tunnel formwork on 2 buildings. So 2 buildings were simultaneously done, and we could achieve a cycle of 45 days for 2 blocks for plus 13 floors. This is our category of stay in place formwork, which is the last one. Here, as the name suggests, the formwork which is there, it becomes a sacrificial formwork, or you can say the loss formwork, which means whatever system you are using, because we have various systems here. But the basic thing is that whatever system you use in the form of block panels or whatever, that will remain part of the structure itself. That will act as a sacrificial or loss formwork. It acts as a formwork, and then after you pour the concrete in between, it becomes part of the structure, either in the form of an insulation or either or as an outer skin, or sometimes it becomes the structural part of the building also. So various type of technologies are available in this category. This is, if you see in the last one also, the person who is putting these blocks, these are EPS, that lightweight material blocks, which are interconnected with some steel connectors, and these blocks are put together. So in this case, it becomes a sacrificial or loss formwork. When you put the concrete, these blocks will remain here, and this, in this case, being an EPS material, the reinforcement is also put as per the requirement of the building. How, after putting all the blocks of EPS and reinforcement if required, and after putting all this, you can do the concreting. This is another variant in this case. If you see these panels, these also looks like white color EPS, but it is not EPS. These are PVC wall forms, and these are very small size panels. If you can see, these are very small size panels, and you connect these panels at the side. The height of the panel is up to the ceiling, and you connect all these panels together, and as per the requirement, you put the reinforcement, and then you do the concreting. The advantage here you get is these are pre-finished panels, PVC, and you don't require any kind of finishing outside, neither in terms of any plastering or even painting. These are totally pre-finished. How it, you can see how it looks like. These are extrusion of done with the extrusion of the PVC material. You have all inside, and for the reinforcement also provision is made. This is how it looks at the site. Our project at Lucknow, the Light House project, is being done using these panels. Although these are load bearing panels, but being a high structure, we are using these panels with the hybrid, in the hybrid mode with the steel frame. You can see the steel frame is there, and the panels are being installed. Just to give you more idea of how the services are being put, all the provisions are there inside. Before you don't have to put any services afterwards. All the electrical, plumbing, water supply, everything you can put before doing the concreting, and nothing to be done after installation of these panels. How the sample flat looks like using this technology. And this project at Lucknow, as I told you, it is also in a very advanced stage and going to be completed very soon. This is also, as I told you, it's a high-rise stilt plus 13 floor. That's why we had to go with the hybrid system using steel frame. And with this, I come to the end of the technology part, like the 6 categories. As I told you, all the technologies which are broadly available in the country now, we can put them in these categories. And the major advantages of using the alternate construction system, these are very fast, as you can see. The optimum use of resources since these are all prefabricated, pre-designed, and you don't have any wastage. As you can see, minimum wastage is there. Pollution is not there at the site since everything comes from the factory itself and you have to just assemble at site. Then this is the industrialized system, means you can planning before, and whatever is the size of the project you can handle easily with the proper planning. Then doing the cost-effective design, you can save a lot. And then since better health conditions, you get better productivity, no pollution, and there is no dust at the site. And the major advantage, the other advantage we get with this systems are low life cycle cost. Here, quality and all the components are basically prefabricated. We get better quality, and due to which you have lesser maintenance cost. Overall, if you see the life cycle cost of these technologies, it will be much less than our conventional system. That the quality issues are there, and a lot of energy and money goes into the seepage issues, and even the plaster goes off, and then reinforcement. Sometimes you see the issues related to that. And as I told, quality products are there. That there are low GHG emissions, and overall you can say these are much sustainable as compared to the conventional system. Here, this is the last slide. I just wanted to show that starting from the zero level, which we do with the raw material at site and bringing them and doing all the work at site in situ construction, we are slowly moving to the next 1, 2, 3, 4 level. Second level where the components are prefabricated in the factory and 2D, as I showed you. And the third level is where we have also reached is the 3D volumetric construction. And now even the fourth level is also being seen in some places where the even recast in the factory, all the services and all the furnishing, even the toilet seats and all those electrical fixtures and everything, furniture is done in the factory itself, and the total module is brought to the site and done. So this is how we are moving from level 0 to level 3 and 4 now. With this, I come to the close of my presentation. If you have any queries, we can take up in the end of the webinar. So, thank you very much. I would now request my colleague, Mr. Jha, to start his presentation.
Is my slide visible, and am I audible?
Yes, you are audible. Slides are also, you can make it full size.
Good afternoon, everyone. I am C.N. Jha, working as Deputy Chief with Building Materials and Technology Promotion Council. And my presentation is on this specific technology, a specific project of Light House Project Ranchi. So this Light House Project Ranchi represents the, like in our this one previous presentation, we have come to know about the 6 distinct broad categories And this technology represents the 3D volumetric precast concrete construction. And the specific technology name which has been given by the technology provider Messrs. Magic Reed is 3D modular precast magic pots. The contents I am going to cover in my presentation. GSTC India has already been covered. 6 lighthouse projects just in a summary form in a table. Then this particular project with primary focus on technology being used with the structural elements, foundation, and this superstructure system. And this I will give brief of design basis and design details also. Then construction sequence and infrastructure items. This has already been shown. Here, the table, this gives the summary of 6 lighthouse projects. You can just compare for the comparison purpose. The one highlighted is of this Lighthouse Project Ranchi. You can see there are 1,008 number of houses in ground plus 8 configuration. The plot area is 31,160 square meter. Carpet area is 29.85. And total project cost and individual DU cost. This individual DU cost includes the internal services, on-site external infrastructure, and social infrastructure also. This is the site layout. You can see the 7 blocks. The 4 are here, 2 are oriented this way, and one block you can see here. And the ground coverage is 29.3% and FAR achieved is 2.21. And all the building blocks, 7 building blocks are of same configuration. And the typical floor plan you can see here. So there are 16 DUs on each floor. They're scattered by this central corridor. And one set of 2 staircases and 2 lifts are there, catering to the requirement of this all 16 DUs. A typical dwelling unit plan you see here. This is how the unit will look like after getting fully finished and with all fixtures and furnitures. So you can see this is the living room. Here is the entrance. And this is the bedroom. This one is kitchen and bath and toilet. And you can see the balcony also approachable through this living room. The carpet area is about 29.85, which is about 5 square meter higher than the minimum requirement of 25 square meter as per NBC. So this is about 20% higher and fulfilling the sizes requirement of this NBC. This is set of 4 units and you can see, and the project includes many sustainable features. It has to be green rated as per GRIHA, and the minimum requirement is a 3-star rating. There are use of renewable resources, rainwater harvesting, like all the runoff from the rooftop and from the road and like site area are to be kept within the site only through rainwater harvesting pits. So no flow will go outside. Is like a rainwater harvesting system has been designed as such. Then there are solar lighting as part of the total conventional lighting. So solar lighting will mainly this meet the requirement of common area lighting. There is one STP with 420 kiloliter per day capacity, and this recycling of wastewater has also been kept. So the wastewater would be treated and will be used for this flushing in toilet and for gardening purpose. So dual plumbing system has been designed for this purpose. Firefighting system as per the height requirement of NBC has also been made, and solid waste management also. The conventional system we are all aware of, load bearing and RCC frame structure. Here I will talk of this this system, or this modern system, like our Honorable Prime Minister also highlighted that this is like a Lego blocks to be kept just one by the side of other. So this is a very modern method of building. Like in countries like Singapore, this is quite prevalent nowadays, in which like entire room we have from the earlier presentation also, and in the movie we have seen room, toilet, kitchen, bathroom, staircases, or any combination of these can be cast monolithically in a plant or casting yard in a controlled condition, and that can be transported and through tower crane can be put one above the other and one by the side of the other, and to be integrated together for a complete building unit. As regards this structural elements, so one is foundation and other is superstructure. Here in the superstructure, it is not entirely of 3D modules, but there are certain walling panels and other pods also, which I will cover subsequently in my presentation. And there is solid core pre-stressed slab. Pre-stressed slab is not an necessity, but the site is very close to the aerodrome in Ranchi. And because of some height restriction, so and to slightly reduce the overall height of the building, this solid core precast slab was adopted just to reduce the thickness of the slab. The foundation is conventional only as per this geotechnical investigation report, including the parameters as bearing capacity, this then soil strata, water table, etc. And the raft foundation has been adopted here with shear wall up to the plinth height, and then grade slab is there at plinth level. This level. So the this foundation is conventional only. And the structural system, in the structural system, the primary, one which we want to show and which has been adopted here, primarily is the this one, 3D volumetric rooms or modules. So for producing these 3D components, what we require is 3D steel molds, which is created suiting to the sizes of these rooms which are to be produced. So in this particular project of LHP Ranchi, the kitchen pods and bath pod, which comprises of toilets also. So these two modules, these two 3D modules have been produced as 3D module. So suiting to the size of kitchen and this bath unit, so these molds have been created. Once the molds have been created, so steel, as per the requirement, steel mesh is put in that mold. We have seen in the movie also. And along with this steel mesh, electrical and plumbing lines are set up as per the requirement. And all the blocks, the blockouts for door and windows are also set up at the same time. You can see here, you can see the window, this window cutout. So while after the mold, you have inserted the steel and all, then you block all these sides so that concrete doesn't flow out and it is passage is blocked. And once you have done all this, then you pour the high performance concrete into this. And after that, you do the demolding. And after only the strict quality checks, each pod are transported for erection and assembly at the site. And why I am saying that strict quality checks, any defects in the wall in the form of crack or anything, so even in the unevenness in the thickness and all, so if those things are observed, so those pieces are rejected. And only the units which conform to the quality parameters, then only they are transported and used. Here you see the 3D, this one, mold, which is, this is actual site photograph from the casting yard. So this is for like producing 3D room. And similarly for the other walling components also, you can see. So both type of components are being produced. This on the left side, you see a very long, it is about 65 to 70 meter long. It is for pre-stressed slab. So in this pre-stressed slab, you can see the reinforcement. So those are first this stressed and then concrete is put. So this is for this floor slab, which is pre-stressed. And you can see the series of molds for 3D modules. Similarly, the operation within the casting yard. And this you see the slab or wall components are being casted. So what are the advantages of these systems? Like you must have come to know the advantages also, because you can visualize the advantages. Up to 90% of the building work, including finishing, can be completed in plant or casting yard, leading to significant reduction in construction and occupancy time. Here, I would mention that in case of Ranchi, this one casting yard area and storage area was very limited. So the construction agency faced difficulty because of this. And the finishing part, like they plan to finish the at least bath and the toilet pods fully, along with the like floor tiling and the wall tiling and even the pods and all. So all the fixtures also. But because of the this storage area, they could not work on those finishing aspects, and they could not complete the finishing. So here in this case, it is not 90%, but slightly lower than that. But they are capable of achieving this also, finishing part also. And so that like this ratio can be increased up to 90% also. The controlled factory environment brings resource optimization, improved quality, precise and finish. Like most of you are aware that in this one casting yard kind of environment, or the this one plant, you can exercise this one controlled factory environment. Like you have very good platform to work on. You have a very sophisticated mold. You have this protocol of cleaning that mold, then this maintaining the accurate thickness and all. You have a trained manpower. So these all result into very good resource optimization and improved quality, which like at site at various positions and at various site this height is not possible to maintain. The concrete can be designed like it is applicable to the this one in situ concrete also, with the this one byproducts such as fly ash, ground granulated blast furnace slag, microsilica, etc., resulting in improved workability, durability, and resource conservation of OPC, while also conserving the natural resources. In this project, ground granulated blast furnace slag and perhaps silica fume is also used in the concrete. And the ground granulated blast furnace slag, which has been used in this project, is to the extent of 64%. It was like available from this one Dhanwad plant of ACC, and which the construction agency has used, which comprised of 64% blast furnace slag and only this one 36% OPC. So this is something which is unheard kind of thing, because you know that in precast concrete components, the fast strength development is the very crucial factor. And with these incorporation of fly ash and silica fume, so strength development is slightly slower in the initial stage, though in the final stage or after 30 days, so strength development is almost catches up, and like strength development is very high after 1 year or after certain years. And even the durability parameters are much superior of this slag-based or fly ash-based concrete in the long run. So they have used this, and how they could achieve this one speed also. So I will cover it subsequently. With a smooth surface, the plastering is also eliminated. You can appreciate that nowadays, like plastering is very labor-intensive job and very time-consuming job. And if you go for a very good this one mold and get very good finish, then plastering is eliminated. And in this case also, the plastering has been eliminated in this project. System is like, you save on the material because like any product is not wasted. So you just keep it and in the casting yard and use it for some other purpose. And at site, it is very neat and clean site. Even the curing water and all can be recycled. So that way also the water use can also be minimized. Shuttering, scaffolding material use is almost minimal or nil, you can see. And better site organization, so you can get with this. But there are some essential requirements also. Like you see that, okay, these are the advantages, but for this kind of construction, you need some very many things, and you need to plan for that. Space for casting yard is required in addition to the site for actual construction. So if somebody is like thinking of doing the construction using this 3D precast, so 3D precast, you need a very adequate space for casting yard and storage space. And in case of 3D construction, it is much higher than the 2D because the components are like with 4 walls and this one slab. So you need to have a very high storage area for keeping those components, which is like in case of 2D, you can put side by side, but 3D and you cannot put immediately one above the other. So you have to put in the horizontal way only. And a requirement of a room with 4 walls and slab is much higher than this one 2D components. Setting up of casting yard requires months in time, and if your plant is located far away, then transportation may not make the project viable. So you need to create this one casting yard at the site itself, and it takes like in months. It takes time, but the advantage is like if you are doing the foundation. So what we have seen in the movie also. So you can do the foundation work parallelly, and parallelly you set up the casting yard also. If you are going for the steam curing, then you need a boiler also, adequate space, and this provision for this boiler can be kept. In case like the strength development is the parameter, and for maintaining the speed of the units you have planned, like 6 DUs if you have planned per day. So you need a cycle to achieve this cycle. You need to have this strength development process fast. Then only you can demold the concrete and use it for erection purpose. So for maintaining this one speed, you need like fast development of strength of the concrete, green concrete. In case of like our code, which is like building design and erection with prefabricated concrete code of practice, they also allow the steam curing because of the simple reason that demolding can be very fast and you achieve this one higher cycle. So in this Ranchi project also, this boiler was kept for steam curing process. And they use a SCADA, this one, supervisory control and data acquisition system also to ensure the real-time monitoring and control in terms of all the components, whether they are getting adequate steam of required temperature and required duration. Like they have gone for 3 to 6 hours of steam curing at a 80-degree temperature. So through SCADA, system, they have ensured that on the real-time basis that all the components are getting the adequate duration and temperature. Approach road to site for the movement of high capacity trailers, cranes, etc. So as like we see that this requires tower crane because the module's weight is very high. So this high capacity tower cranes and even trailers are required. So you need a very good approach road with required width and right of way, so that your it can be taken care of like trailers can run and trailers can easily approach all the places. Site should have space for proper leveraging and functioning of cranes, because everything is done by the crane only. And generally our building bylaws allows the gap between the two building structures. So, but still, like, you have to assess where you will put the foundation of the tower crane so that you can leverage, and whether you have space for right space for those operations also. So that you have to assess beforehand. Requires skilled labor and strict supervision. And plumbing and electrical services you need to plan, because after putting that services only you do the pouring of concrete, and subsequently it is difficult. Here in this case, the technology provider, the construction agency is the Messrs SGC Magic Reed LLP, and technology provider is Magic Reed Building Solutions. And here third-party quality assurance have also been appointed, and those who are like their personals, their technical persons have been deployed at the site also, and the agency is Cube of IIT Madras. Some design basis, like briefly, the superstructure is designed as shear wall system, as in the monolithic concrete construction. Wind speed is very basic here. Basic wind speed is 39 meters per second. You can see this is like from our vulnerability atlas of India. And this is very basic zone, like from the lowest, like low damage risk zones, just upper, this moderate damage risk zone B with a speed of 39 meters per second. So very moderate kind of, and very safe wind speed is there. Similarly, earthquake also, it is in the lowest category, though this earthquake code is getting revised, but as per the earlier code, this is in zone 2, which is the lowest zone. Very low damage risk zone, zone 2. So from that angle, wind and earthquake, this is very safe zone, Ranchi. And as per the codal provision, design has been made. Then comes the construction sequence. So construction sequence, like we have already seen that the foundation is a raft foundation as per the conventional, which is conventional only. And superstructure is combination of like 3D modules, walling components, and some pods also, which I will cover, and solid core pre-stressed slab. Then MEP. MEP is along with the superstructure only. Construction sequence in the project. Design foundation of the building is getting ready, and while manufacturing of the precast concrete structural modules are taking place at the factory. But like before this, this manufacturing starts, so you need to do the setting up of the precast unit also, and along with the molds and components which is required for your as per your delivery schedule. So if you if you want like 6 units to be erected per day, so you need mold for like if you are going for 3D mold for 2 units, two rooms or 2, then you need to have mold for 12 number of 3D rooms for achieving that speed of 6 units per day. And accordingly, the demolding and all the process parameters. The factory finished building modules are installed at site with the help of tower cranes. Gable end walls are positioned. So this sequence, like I will show you, this is like available subsequently also. Pre-stressed slabs are there, and and all the units are horizontally connected through rebar mesh and structural screed. So now this is starting from the foundation. I will just briefly show you the structural drawings. So this is raft of 700 mm thick. Then shear wall from the raft, it is as a 160 mm. This is the sectional view of the same. Then this one, specification of concrete and steel used in the project, a raft foundation, precast shear wall, and precast partition wall. Means all this one, structural as well as non-structural wall along with the foundation is of M30 concrete. Precast pre-stressed solid slab is M50. Structural screed is M35, which we put after, like for joining horizontally the entire module and all the structures. Then this one, steel specification is also shown. This is the concrete mixed design. You can see for M30, which is the main components, all the walling, foundation and all. So the cement used is slag cement with 390 kg, and water cement ratio is also very good. That is 0.35. So ensuring like high strength and durability. If water cement ratio is lower, then the coarse aggregate and all. And since this is slag cement, so about 64% has been used here, slag component. So that proportion of OPC has been conserved. Picture of the batching plant. Then the start of the foundation work. PCC reinforcement for raft. After 700 mm thick raft has been laid, this wall up to the plinth, this train, and this shows the plinth level framing plan. So I will not. And these are the various structural connections, typical connections. You see that the prefabricated thing are getting connected to this one with the help of screed concrete, with the reinforcement going as per the designed length to the screed concrete to one from one component to the other. Then the screed concrete is done. Is here like. In this like modules, the Grautek coupler has been used. So Grautek coupler, you can see here. So at 4 corners of these this modules, 3D modules, these 4 Grautek coupler at each end has been put. So how this one is connected. So you can see here the top projection. And this is threaded, and steel coming from the upper side of this is threaded into this, and bottom vertical steel, which is projected outside, goes inside this, and once like it has been put, so then you put the grout from the bottom, and which when it starts flowing from the top means the entire space has been filled through grout. So this way the modules have been connected with this Grautek coupler. And again, this one, like animation you see. And this we have seen in the movie also. And so these are kitchen pots and 2 are bath pots. Then other components are coming. And this way, like the construction is taking place. After that, slab will come. You can see this pre-stressed slab on all 4 sides. Then this process is repeated. You can see the 3D modules actually cast at site being supported, then wall panels being supported by this props, inclined props. Then this is H pod. So other components which I was talking. So H component you see. So this is being used in the corridors here, and it looks like this. And this is put like this. Projection is there, and upper projection is not exactly like H, but in the shape of H, but dimension is slightly different, upper and lower. This one. There are iPods. iPods you can see. So this is like this. This is coming in between two rooms, and this is the outer side of the room. You can see the window here also, and this is the inside. Like this is the partition wall acting as partition wall, and this is the inner phase. Then there are, this one is the staircase module, partition panel, and pre-stressed slab. Cable wall, which is like terminating the end, like at the end, which is coming. Then there is sequence of erection also for this prefabricated components. It's not that just they are put. So this comprises of like lifting the precast panel and placing it on its designated location. First you put the this one, any precast panel. Then there is it needs to be aligned. So adjust the panel to position and secure it with diagonal props. You can secure the position with the diagonal props. Again, check the alignment and verticality of the panel. If necessary, adjust the temporary propping to achieve the level and position of the precast element. Then check the stability of erected props before releasing the hoisting cable. Like you don't immediately release the cable. You just first assess that whether like it is stable, then only you release the cable. Carry out the stage passing QC inspection after the erection of element and before grouting. And what you see, before grouting, you check the joint width between the panels is within the designed design allowances or not. Then you do the grouting. Prepare and apply this one non-shrink grout to seal all the gaps and check whether all the joints have been properly sealed. Only after that, like installation of subsequent precast panel above the erected precast panel is done. And before that, you need to keep the intact for the 24 hours. That point I have missed. So you need to keep intact, and only after 24 hours you need to install the subsequent precast panel on the top of this. Then repeat this one. So this is the erection sequence. So this is the like intermediate phase, and like in the movie you see the starting of the project, but now it is almost 90% finished. And this you see how it looks like from the top. You see this one precast slab is this installation is taking place here, and along with that, like modules, 3D module of this one is like bath pod, and this one is the kitchen top, kitchen module. So this is being put. So this is the actual construction time photograph. And now this is the stage of the building. You see that almost this is finished. And inside also you see drawing room, and this one is the kitchen. The present stage is like you can see that there were total about 10,784 components, which the production of the same has been completed at the casting yard, and they are getting it dismantled also, because all the components have been produced. Out of 7 blocks, 6 blocks have been completed. Like erection and finishing is also in advanced stage. Only in the block number 4, the parapet wall is in progress. Is nearly complete, though nearly complete, but this one is in progress. And infrastructure work, boundary wall completed 56%, and other part which is not completed because this has been encroached, and once like the building project is completed, so that will also be done. And after they completely this one dismantle the casting yard. And STP and UZ water tank, the civil work has been completed and now the machinery installation is going on. Road and external electrification is also in progress. So this project, as in the movie, you have seen that this project was not started on 1st January 2021. This started quite late. In fact, like October or from starting November, this project started in 2021. And during early this one, 2022, so the entire state faced this one issue of availability of sand. And then after facing the difficulty, they did the mix composition, design mix with crushed stone dust, crushed this one stone. And they found it like better than the this one sand. But this all experimentation and then this banning of sand, so that took time. So and they faced space constraint also. So because of this, projects got slightly delayed, and now it is like at advanced stage of completion. So with this, I this one my presentation and to all. And now I invite our international speaker, Dr. Sabine, to present her this one. To make her presentation, I'm just
Thank you, Mr. Shah. Give me 1 minute to share the right presentation. So I guess now you can see the right slides, the right design. So hello everyone. I am very happy to be here again today to share our perspective on the Lighthouse project in Ranchi. Let's start by briefly introducing myself and the research institution where I work. And I would also like to explain briefly what our role was in the 6 Lighthouse projects. So my name is Sabine Gigelmeier. I am working at the Fraunhofer Institute for Building Physics, IBP, in Germany, in South Germany. There I am a business development manager and scientist. And one focus of my work is on the topic of sustainable buildings. This includes the use of climate-friendly building materials as well as energy-efficient building operation. And it is from this perspective that I, together with some colleagues of mine, have looked at and analyzed the LHPs. At our institute, the Fraunhofer Institute for Building Physics, we focus on 6 research areas, which you see here. It is acoustics, it is energy efficiency and indoor climate. It is life cycle engineering, hygrothermics, which is about heat and moisture transfer in buildings. We focus on inorganic materials and recycling, and also on environment, hygiene, and sensor technology. We have 2 branches in Germany, both in the southern part, and I'm working in Holzkirchen in Bavaria. And we conduct research in a wide variety of areas related to construction, and we also do that a lot in cooperation with international partners. We work often and we like to work with local partners like local universities or companies or governmental units, and like we did it here in this project. Our institute is part of a big research society, the Fraunhofer Society on Applied Science. It is the biggest institute for applied research in Germany with around 30,000 employees in almost 80 institutes and research units all over Germany. We also have offices in different countries, for example, in China, the USA, and also in India. We do applied research. We do not do basic research. That means our research always needs to be able to be applied on the market. And this is also reflected in our financing structure. So we have to generate 2/3 of our budget ourselves through publicly funded projects and research commissioned by companies. The remaining third is given to the institutes by the government as basic funding. And all of our institutes focus on technical aspects like medicine, production, technology, robots, work organization, and of course, building construction. We have an office in India, as I already said, and this is our central point of contact for all projects that we do at Fraunhofer that we carry out with Indian partners. The office has already been established 15 years ago, and it generates a revenue of about 50 million euros in the last 10 years. And on the map, you can see an overview of where the different institutes have already carried out projects in India. And these projects often revolve around the topics production technology, renewable energy, smart cities, artificial intelligence, electromobility, clean tech and sustainability, and also, of course, building construction. And in case you are interested in research cooperation, feel free to directly contact me or our colleagues from the India office. We are always happy to discuss any research ideas. So what did we do in the Light House projects and the Technograhis program? We had mainly two tasks to fulfill in this project, and the first one was to develop short video e-modules on the LHP technologies. So we created extensive material that Technograhis can use to learn about the technologies of the Lighthouse projects themselves. For example, on the topics of thermal comfort, energy efficiency, or others. There are 36 short videos already available on the different aspects of the buildings of the Lighthouse projects. You can find them on the link below or on the YouTube channel of the BMTPC. Our second task in the project is to share our international knowledge, experience, and best practices on the different Lighthouse project technologies. And we also share knowledge about the technologies in other formats, such as live presentations on specific focus topics, or, for example, our experience or our focus or our point of view on some technologies like we do it today in this webinar. You heard a lot already about the 6 Lighthouse projects. We did e-learning modules on all of them, and we did 6 short videos on each of it. So for example, for Chennai and also for Ranchi, Lucknow, and all the others, we have 6 e-learning videos each, which focus about some short introduction, which give some information about the heat and moisture transport, how it is happening in the specific Lighthouse project. We are talking about how the specific technologies could be improved regarding the energy efficiency, or how we could improve the thermal comfort in the buildings. We focus on how to optimize durability, and in each module we also give like a short overview over further development potentials, like what could we do to increase sustainability, for the specific technologies. Today we are focusing on the Lighthouse project in Ranchi, and what I want to do now with you is we want to focus on the most important aspects from our point of view regarding the construction technique. So I will give you like the main points we found out during our analysis, and if you want to dive deep into our learnings, then visit the e-learnings on the Technograhis platform. So before we take a closer look at the technology that is used in Ranchi, let's first understand the climate conditions there. It's important to know that not all construction methods work equally well in all types of weather. A building technique that works in warm and humid areas might not be suitable in places that experience frosty winters and the other way around. So when evaluating a technology, it's crucial to consider the specific weather conditions in the area. Ranchi lays in the eastern part of India in a subtropical climate zone. The rainy season is from June to mid-October, and in the summertime it's rather hot and the maximum temperatures go up to 40 degrees. In the wintertime it is getting slightly cool, but there is usually no frost. So the challenge with buildings there will be that we avoid overheating for the people in the buildings. That is what we will be focusing on. Heating, on the other hand, will not play a major role as it's not getting too cold in the winter months. Let's quickly recap what the construction system was about. I guess we can go over it very quickly as you heard a lot about it already. The construction type used in Ranchi is made with magic pots, like formwork modules. And these magic pots are poured with concrete to create room models, 3D volumetric elements. This prefabrication reduces the construction time on-site, and therefore the environmental conditions can be controlled and managed during production. This allows high standard quality of prefabricated components, and the formwork or molds can be used again and again. The concrete pots are stacked on-site and the slabs are poured on-site for monolithic connection between modules. So we have a very fast construction and we have a good quality control during the process, as we have a defined process for the production of these single modules. As said before, heat protection is a major task in Ranchi, as the temperatures get very hot during summertime. We have different options to design buildings to improve the thermal comfort for the residents. In the previous webinars, we were already learning what comfort enhancement we can reach through measures like, for example, shading, insulation, or cool colors. Rooms overheat primarily when too much sunlight enters the room. Thus, in this webinar, we want to have a look at options regarding the window design to avoid overheating. With a comprehensive design of windows, we can reduce the solar gain significantly. And in the next few slides, we will look at this in more detail. Specifically, we will have a look at the radiation and heat transmission through windows. Let's start at the very beginning. On the left-hand side, we see a wall opening through which the solar radiation that we call I is coming from the sun is transmitted to the room. This is what we call transmission. Normally, we do not just have openings in our buildings, but install windows. And if we do so, we add a barrier for the solar radiation. At this barrier, one part of the solar radiation is blocked from entering the room by absorption, which heats up the glass. Moreover, another part of the solar radiation is reflected at the surface of the window glass. We therefore can conclude that the solar radiation I coming from the sun is reduced by the reflection and absorption, so the total radiation entering the room is reduced. We can calculate this reduction by using a factor G. If windows are installed with more than one pane, these reductions will occur on each pane, reducing the transmitted energy even more. And you can see the radiation path here on the right side of the slide. The factor G we have introduced is used to calculate the amount of energy which is transmitted to the room. In building physics, we call it the G value, the total energy transmittance, which includes the primary radiation through transmission and the so-called secondary energy supply through the heated panes by absorption. The G value is a characteristic for different window types, and it can be calculated and measured. Most producers of windows will give you the G value for their product. So let us now have a look at some typical G values. As we have seen before, single glazing reduces the radiation by reflectance and absorptance, leading to a G value of 0.75 to 0.87. This value indicates that 75 to 87% of the solar radiation from the sun will enter the room. So the lower the G value, the less energy reaches the room, and the less energy enters the room that can overheat the room. If we now look at different windows with different glazing, we see that the G values can be reduced from 0.87 to 0.12 if we additionally use an external solar protection. The best insulation against radiant energy is providing glazing with external shading. But also a clear glass with internal sun protection devices can improve the G value a lot. And also some absorbent layers on the glass can improve the G value. To give you an impression on how much energy still reaches the room, here is the same table again, but now with the radiation energy I arriving in the room depending on the type of glaze. Based on a solar radiation of 3,400 kilowatt hours per square meter in year, multiplied with the respective G value, this radiation is calculated. So also it is visible that the glazing with external shading offers the best protection against the sun. Let's now compare the effect of different glazing types specifically for the flats in Ranchi. The evaluation has been done by comparison of the solar radiation entering the room through 1 square meter of window area. On the left-hand side, we see the solar radiation in watt per square meter, and down here we see the time, the hours of one day. Each dot of this plot represents the radiation to the room per 1 hour, calculated using a simulation program with a model of the Ranchi flat. In this graph, all days of the year are plotted. With this, the upper closing curve, it's here, is the maximum radiation that occurs at noon with approximately 3,100 watt per square meter. In the same manner as before, the next variant we calculated was the double pane window. This is displayed as blue dots now. The red line in the diagram shows the upper values of the single pane glazing as a reference. We see that in comparison to the single pane window, the radiation entering the room is reduced over the whole day, as well as the maximum, which occurs also at noon, and is now at around 2,700 watt per square meter. If we now add a solar shading to the double pane window, we again see a reduction of the solar radiation, indicated now as green dots. For comparison, the red and blue curves of the two other variants are shown in this graph. By adding a solar shading to this window, a reduction of the maximum solar radiation into the room to approximately 650 watt per square meter is achieved. Moreover, we also see that the maximum is no longer a peak, but it is a period between 8 a.m. and 4 p.m. The differences are also visible by just looking at the three closing curves, as you can see it here. So let's conclude. Double glazing is better than single glazing, but the most effective measure is the solar shading. The solar input is not only the significant influence for the thermal comfort of the occupants, but also has a high influence on the energy efficiency of the building. And we will now take a closer look at this. If you have already attended the previous webinars, you will already be familiar with the energy balancing equation that you see here. What you see here is a representation of the energy balance method. It says that, on the one hand, a building absorbs energy. So you have energy sources. And on the other hand, a building also releases energy. You have so-called energy sinks. If there is a difference between sources and sinks, that means that it is out of balance and you need to dissipate energy, for example, through active cooling, or supply energy in order to ensure comfortable living, for example, through heating. In this example, our gains are lower than our sinks. That means we have a resulting heating demand to ensure comfortable conditions. Here on the left side, you see that we have solar gains and internal gains as energy sources. We already talked about solar gains. And internal gains means all energy that is brought into the room from inside. For example, through the residents that emit heat from their body, or from electrical devices that also emit heat into the room. On the right side, you see the energy sinks. Energy leaves the building through transmission and also through ventilation. As we are focusing on solar gains in this webinar, we will now take a look at how large this value, QS, the solar gain, becomes, and on which factors it depends and how it is calculated. QS is the solar gains and is described with this equation that you see here. It represents the sum of all windows and has watt as its unit. The individual elements that must be multiplied for each window are AI, which is the window's surface, the respective window area in square meter, and in addition there is the G value of the window, which we already discussed. It is unitless and, in short, describes the total transmission of energy through the window, which you heard already before. Finally, the value of the solar irradiance, I, is multiplied with the unit watt per square meter. If this calculation is carried out for each window and added to a total sum, this then describes the QS value, the total solar irradiance. So let's go back to the solar irradiance I again. This value depends on meteorological boundary conditions. Depending on the location, the course of the sun, and thus the angle of incidence, differ and can be described as the resulting irradiation that hits the Earth's surface. Depending on the time, the position of the sun changes, and therefore the irradiation on the surface differ also. Moreover, the compass direction, the incident changes as depicted in this graph. The displayed global radiation is the total value of the radiation, which means the sum of the direct radiation and the diffuse radiation. So that's the theory. Now let's look at a practical example of how the calculation of the QS value works. As already said, for each window, you'll have to calculate the solar gain and sum them up all together. As a result, you get the total solar gain of the flat. If you want to get the gain of the whole building, you sum up all windows of the whole building. In this case, as you can see, the exemplary flat in Ranchi has a total of 5 windows. The areas of the windows are 2 square meter, which is here, twice it's 1.8 square meters, and twice there are small windows with 0.75 square meters. The orientation of the flat means that the windows here are directed to the east, with a solar irradiation of 600 watt per square meter. The windows here are directed towards the south, which results in an I value of 650 watt per square meter. So let's put these two values into the equation. To calculate the equation, the respective G values of the windows are still missing. Depending on the type of window that is chosen, different G values, which also significant influences into the overall equation. So let's start a first calculation where we calculate the example flat with variant 1 of the G value, which means we assume that we have a single glazing of the windows here. The total irradiation QS for the flat is then 3700 watt. So let's calculate a second variation of the G value where we have windows with double glazing. It results in a QS value of 3300 watt. And let's calculate a third variant with external shading, and this reduces the QS value of the dwelling compared to variant 1 by a factor of about 7 to 520 watt. So we can see that the QS value depends on the type of window, but the decisive factor is whether or not shading is installed. If you want to dive even deeper into this topic, I recommend to you to check our e-learning videos on the BMTPC website. Let's move on now to the next aspect that we usually look at when analyzing buildings and construction methods: the thermal properties of the building envelope. As we discussed earlier, the outdoor climate plays a significant role in the resulting indoor climate. We have looked at how the solar input from outside through the windows can heat up the room. Another significant role is, of course, played by the insulation value of the entire exterior wall, the thermal conductivity. The higher the thermal conductivity of a material, the easier it is for heat to flow from the outside through the wall and into the room. Or looked at the other way around, the lower the thermal conductivity of the building's envelope, the more the interior is isolated from the climate outside. As a rule, we want to achieve the lowest possible thermal conductivity for energy-efficient buildings. For our analysis, we need this property for all materials used in the building envelope, like the concrete or the windows, But how is this characteristic value determined? If you do not get these from the producer, the only way to get them is to determine them by using measurements in the laboratory. Therefore, in the following we will see the typical measurement methods for the determination of thermal building material parameters. But let us first have a look at the material itself. Although we do know the properties of monomaterials, often we have to deal with new materials which may be composite, as you can see one example here, which is a reinforced concrete structure with steel and concrete components. As mentioned, we know the parameters of individual components, but we cannot make any statement about how the materials behave in the composite. Let's have a look at an example as depicted here. We do have the properties of the concrete as well as the properties of the steel, but we cannot know the properties of the composite unless we measure the combined material in the laboratory. And how do we do that? You see here a guarded hot plate measuring device. And with this device, such building material samples with dimensions of 20 to 20 centimeter, we can precisely examine. In order to do so, a sample has to be put between two plates. One of these plates is heated and the other one is cooled. This generates a temperature gradient, and this forces the energy to flow through the sample. The temperature difference above and below the sample is measured, and the energy required to keep the temperature difference constant is determined. This allows the heat flow to be determined and the thermal conductivity to be calculated. The thermal conductivity of a material is also called lambda value. These lambda values are later used to calculate the U values of building envelopes. On the picture you can see a colleague of mine at the Fraunhofer Institute for Building Physics who is putting a sample into the guarded hot plate device. These devices come in different variants and they differ in the dimensions of the samples possible to be measured within, but also in the temperature range and angle in which measurements can be performed. In this picture you can see one example device which is capable to measure composite materials as we have seen it earlier, but is also capable to be tilted. Inside the device, different modules are installed. These make sure that the heat flow runs always vertical through the sample, even if the device is tilted. This is needed so that the measured heat flow gives only the heat flow through the sample. This has to be true even if the measuring is not made vertical but tilted, for example due to measurement of pitched roof components. It is necessary to exclude all heat flows not going through the sample, as out of the measured heat flows the thermal conductivity is calculated, and even small mistakes in this measurement can lead to huge variation in the lambda values. So the devices themselves, but also the handling, is not easy and should be performed from specially trained personnel only. As we have now seen how to measure the heat flow directly and the thermal conductivity indirectly, let us have a look at another measuring device. We refer to this device as the climate simulator. With this measuring station, we can introduce particularly high irradiations on materials or components. This is used on the one hand side to mimic different stress situations on building components in order to find out how durable they are in different climatic conditions. On the other hand, we can also measure the heat through an opaque or transparent material entering the room behind. The device itself consists of daylight lamps, which are capable to produce the whole light spectrum of the sun, especially the UV wavelength. You can see these lamps also in the left picture here. On the right picture, you can see a setup experiment with the second part of the device. With this second part, the energy introduced through the lamps is balanced and measured. In the picture, you can see the insulated pipe going from the radiated component to the cooling device. But now let's go to the next and last topic of the presentation. This brings me to the end of the evaluation of the technology in Ranchi. And now I would like to talk about one last topic, but one that I think is very important for the future of construction. In Ranchi and in the other LHPs, the material used is mostly concrete. We had already discussed at the beginning that this material has many advantages. It is inexpensive, it can be used to create a lot of living space very quickly, and it is very stable and durable, even in very demanding environments. At the same time, the material is not particularly climate friendly, and it makes sense to consider in the medium term whether there is room for improvement in the choice of material. Why is it like that? Each year we use a very high amount of concrete worldwide. And with this very extensive use of concrete, we have to face some challenges. So we have an annual need for around 50 billion tons of building sand each year. If we would build a wall out of it, this would give a wall with a width of 30 meters and a height of 30 meters built around the equator each year. In the medium term, we will have a global shortage of building sand resources, and in some countries, we are already today facing this scarcity. The high use of concrete also leads to social problems. The cement industry is responsible for a very high CO2 emission. It's around 2.8 billion tons per year. So we need to reduce this high CO2 emissions in the cement industry very soon to reduce climate change. Right now, we do not have a real recycling in the construction industry, so we produce also high amounts of waste. So we need techniques to get back material out of waste. We have different options to improve the carbon footprint of concrete. On the one hand, we could change the concrete mixture. We could, for example, use ultra-high performance concrete, and so we need less material. The next option is we could substitute concrete by other materials with comparable properties, but lower CO2 emissions during production. For example, with geopolymers, which have very similar properties, but they do not need any cement and need much less energy during production. We can also use additives to improve the carbon footprint. So one option is to add rice husk ash, or another option is to add biochar. And we can also do an end-of-life improvement, which means we can recycle materials like concrete. In further webinars in this series, we already discussed some of these potentials, for example, the concrete recycling. Now we want to focus on one additive that can improve the carbon footprint of a building material, which is biochar. As you know, the cement production generates high CO2 emissions. But at the same time, cement-based building materials have positive properties like stability, durability, and affordability. So we can use biochar to improve the carbon footprint of concrete. So what is biochar? You see an sample here on the left side. It is derived from plant biomass such as straw, green cuttings, solid manure, slurry, or sewage sludge. It is produced over pyrolysis, which means that the material is burned without any oxygen supply. The carbon storage in biochar over the long term, there is a carbon storage in biochar over the long term, and this stored carbon is not emitted into the atmosphere, but it is bound on the ground, where it could reduce the effects on the atmosphere. To really get this process of storing carbon in biochar going, we need a profitable application of biochar. So we have it, but how do we use it? One use is in agriculture right now, but there are also potential applications as additive in building materials, for example, in concrete or in mortar. And here we do a lot of research on the Fraunhofer Institute for Building Physics. Here you can see a video that we filmed in our laboratories. You see the individual components that can be used in the production of that mortar. It is cement, gravel, sand, water, and biochar. The mixing process and the ingredients, except for the biochar, do not differ from the standardized production of mortar. So it is just mixed together like you would do it without the biochar. But due to the high porosity of the carbon material, the water content of the mixture must be adjusted. Here you see a colleague of mine who is preparing some samples of mortar, which will then be tested in our facilities, like strength, durability, and all this stuff. So you can see here, it's just like usual mortar. You can use it and apply it like you would do it without any specific additives. You see it's more dark, it's because of the biochar. So you can also use it to color it. These pictures show the material under the microscope, and ideally we see a mortar in which the carbon material has dispersed well in the cement matrix. Of course, this depends on the biochar's particle size. The test specimen now pass through all test procedures which building material must go through. The effects of biochar in cement mortar can be noticed already during production. So the addition of this biochar changes significantly the viscosity and the water demand of the mortar. The following building material tests, we will notice that the mechanical strength of the mortar specimen decrease with an increased content of carbon. In some, you will notice changes in more or less all tests. This means that depending on the properties of the biochar, its addition in cement mortars is limited to a few percent. Up to 2% the changes are slight and even acceptable. At the moment, regulations currently allow us only very small quantities to add them to mortar as a coloring agent. And in order to improve the eco-balance of a building material, the proportion must be increased. However, we can see that a lot is currently happening in the market. Cement producers are under very high pressure to significantly improve the life cycle assessment of their products in the near future. We therefore expect numerous products with biochar additions to come onto the market in the coming years. And with that, I want to close this presentation today. As I said before, if you like to dive even deeper into the presented topics, you now have the opportunity to do so on the platform of the Global Housing Technology Challenge. There you will find this extensive e-learnings on the various aspects of the technology in Ranchi, but also all the others LHP. So thank you for the attention.
Okay. Thank you, Sabain. It was a wonderful lecture. Govinda, if you are there, can you just sum it up and propose vote of thanks? Govinda? I don't think Govinda is there. So on behalf of Ministry of Housing and Urban Affairs, GIZ, and on behalf of BMGPC, I first of all thank you, Sabain, for such a wonderful lecture. It was quite thought-provoking, and I sincerely hope that the participant must have learned about the thermal measurements and how to capture thermal things and climate aspects. Thank you very much for being part of this endeavor of educating and spreading awareness about thermal and other aspects as regards innovative technologies. So, dear participants, I don't think you have asked any questions. So, with this, we come to the end of today's proceeding. And now we will have next webinar, which will be on Light House Project at Agartala. And we will pretty soon be, sending you communication regarding that along with the link. So thank you very much. And if all of you are there, if you can just switch on your video so that we can take a photograph. If all of you can switch on your video, we can take a photograph. Okay then. Okay then, thank you very much. Thank you, Sabai.
Thank you and good afternoon.
Okay, bye.
Bye.
If you read,